Hello everyone. In this example, we will study how the breakaway point determinations. Actually, here we will find a polynomial which is higher than the second order polynomial for the calculation of the breakaway point. And step by step, I will just first calculate whatever we know. That is number of poles, open loop poles. This is 4. What are the locations? S is equal to 0, S is equal to -3, and from this I just go and calculate this. S square plus 2s plus 2 equal to 0 will give you -2 plus minus root over b square 4 minus 4 is 8 by 2, that means plus minus root over -4 by 2 minus 2 plus minus j 2 by 2, that is -1 plus minus j1. So we get the two poles like -1 plus j1 and one pole is -1 minus j1. So these are the two complex poles. So we get s is equal to -1 plus j1 and s is equal to -1 minus j1. So these are the four open loop poles we get. Okay, so that is small m. Next we will have to find out the small m, that is 0 here. So definitely total number of branches is equal to 4 and number of branches terminating at infinity, branches terminating at infinity is equal to 4, because there is no 0, so no question of terminating on 0. So 4 branches will terminate at infinity. Once this will terminate at infinity, so do say so along the asymptotes. So next step is to find out phi a, that is 2q plus 1 80 degree by n minus m. Q is equal to 0 1 up to n minus m minus 1. So what is the value of n minus 1? 3. That means Q will be having 4 values, 1 2 and 3. So we will be having phi a 1, phi a 2, that is phi a 1 when Q is equal to 0, you get this is 4, so 45 degree. Next phi a 2, this is 4, 45 into, you see, 135 degree. Next phi a 3, that is, you see, 225 degree, and phi a 4, that is 315 degree. Just putting the values of Q is equal to 0 1 2 and 3. So once you put, we will get 4 asymptotes. Once you get 4 asymptotes, definitely there is a question comes to find out the next part is centroid. So where they will meet in the real axis, that is known as the centroid. So next step we'll have to find out the centroid. Now coming to the calculation of the centroid. Okay, so we get centroid. We know the real part of the summation, real part of the pole minus summation real part of the 0. So real part of the pole means 0 minus 3 minus 1 and minus 1. So summation means 0 minus 3 minus 1 minus summation real part of the 0 means 0 divided by 4. That means minus 5 by 4. That gives you minus 1.25. So minus 1.25 is the centroid where all these asymptotes will meet on the real axis, right? And we have the 4 asymptotes, that is 4 angles through which these 4 branches originating from open loop poles will terminate at infinity, right? So next step, we will place all these poles on the graph and find out the branches on the real axis, that is root locus branches which exist on the real axis. Okay, see what you get, that is there is plane, real axis, imaginary axis, and poles. X is equal to 0, there is a pole with value k is equal to 0 right here, and you see this is s is equal to you see this is -3, but you get the value of k is equal to 0 again. And here k at s is equal to -1 plus j1, there is a pole with k is equal to 0. Similarly here also there is a pole. So now find out the total number of poles on that means the real axis, the branches on the real axis of the root locus. So how to find out? We will consider only the poles and zeros on the real axis. To find out this step, what you have to do, we have to consider only poles and zeros on the real axis. That means to get the branches on the real axis, we have to consider only the poles and zeros on this real axis, not this. That means this pole and this pole will not be considered, right? Will not be considered. So we will consider the point on this point. So right hand side of this, nothing. Next we will consider the point in between these two positions, that is left hand side of this part. So if this point is considered, what is the total number of pole plus 0 at the right hand side of this point? Total number of pole plus 0 at this point is 1, because we are considering only the number of poles and zeros on the real axis, okay. So that is 1. 1 means this is odd. If this is odd, we will have branch. So there is a branch, right? We get branch. Fine. So once you get a branch between the two poles, see, automatically what comes to your mind? The concept of breakaway point, right? Because the thing is that these two poles are connected by a branch and they are staying side by side. So there is a definitely breakaway point. So we have to find out the breakaway point, and here there will be certain kind of problem we will face, and we will detect the problem, we will solve the problem, right? But breakaway point determination is required. So I will remember all this part and we will concentrate to find out the breakaway point and see where the breakaway point actually lies. That is very important again. Breakaway point definitely lies between these 2 points. That means between s is equal to 0 and s is equal to -3. Not at all possible to get the breakaway point outside this range. So range of the breakaway point is known to us from the graph. The breakaway point is within this range. That means between s is equal to 0 and s is equal to -3. Okay, between s is equal to 0 and s is equal to -3 here I am taking. So we will have 1 plus GSHS equal to 0. That means 1 plus ky s into s plus 3 into s square plus 2s plus 2 equal to 0. That gives you, that is s square plus 3s into s square plus, just multiply this all term, k is equal to 0. That means k is equal to minus of s square plus 3s into s square plus 2s plus 2. Okay, so this is your k. What is the value of k then? We may write the value of k equal to, you see, minus s to the power 4 plus 2s square plus 6s, s to the power 4 plus 2s, s to the power 4 plus 2s cube plus 2s square plus 3s cube plus 6s square plus 6s. You see, this is equivalent to s to the power 4 plus 5s cube plus 8s square plus 6s, if I am not wrong. So dk by ds, this will be equal to minus, you see, 4s cube plus 15s square plus 16s plus 6, right? 4s cube plus 15s square plus 16s plus 6. So this will be equal to 0. So we get, this is your functions. That means 4s cube plus 15s square plus 16s plus 6, sorry, equal to 0. You see, this is the third order equation, and by using Sridhar and all this, we cannot find out the solution of it. So if the order of this polynomial of decay ds, this is a kind of polynomial, you can say delta s or fs, right? So if this polynomial fs is having degree higher than 2, so normal traditional Sridhar based formula will not help you. So in that case, what you have to do, maybe this is 4th order, maybe 5th order, for every solutions we will be having numerical methods. Okay, now I will show you how to get the solutions, that means approximate solutions. Okay, so this is the table I have found. How you have to make this table come to the point. So this was your dkds is equal to 0, that means this is the third order, and we call it a function fs, and we have to make one table like this. What is the table? Actually, you see from the graph, there is a point s is equal to 0 and s is equal to -3. So in between these 2 points, breakaway point is actually line. So we know the end points. So we are taking 3 columns like this. What is this? This is s, the value of s, and this is the value of fs. Once the value of s will vary, fs will be vary, and we are interested to find out the sign. That means the quantity we are getting and what is the sign of it, right? So first of all, we are getting two values, because two values we know, one is at s is equal to 0, one is at s is equal to -3. So we are taking two values, one is 0, one is -3, and put this value of s is equal to 0 there and get this is 6. That means +6. So sign is plus, positive. And once this is -3, that corresponds to fs is equal to -15. -15 means this is negative. That means the range is like this. We will just go on decreasing the range like this. Okay, this is 0 and this is -3. These are the 2 points given to us, right? Now here we are getting the positive values, here we are getting the negative values, right? That means that is lying in between this, in between positive and negative. So we are just dividing this range into half, that is 0 and -3, -1.5. This is your first iterations, right? This is your first iterations, and we get s is equal to -1.5, and if you put this -1.5 here, we are getting 2.25. Again, this is positive, so here this value is -1.5, and value is on the scale, this is positive, right? So what is our rule? Our rule is that if these values, so if you are getting the values which are lying between positive and negative, that means the values is your reference. That means you are going to get the values which is actually lying between positive and negative sign. So here you see, this is positive and this is positive, this is positive and negative. So the range of calculations had been halved. That means this is not lying in this region. So what is the range? Minus and plus. So we have taken two values, -3 and -1.5, and we will just make the half of it, -3 and -1.5. That means the middle value is -2.25, right? This is -2.25, and try to get what I am trying to share. So this is your -2.25, and once this you put in the value of s, this is your second iterations, and you get the value is calculated. Once you put this value of s is -2.25, this is 0.375. That means this is positive again. So this value is you are getting positive. Our aim is to get, because the rule is that must be within the positive and negative. That means this range is again not valid. So the value, actual solution of this fs lies between these two, right? Between -3 and -2.25, right? So if this is between -3 and -2.25, that is our third iteration, that is -2.265. So -2.265 we get 2.33, that is again positive, right? So in between this where the value -2.265. So here also we are getting the positive value. So this range is again invalid, right? So what is this? You must have the value, because it is your fourth iterations, and this we will take as our solutions, right? So that is -3, and in between -3 and -2.265. What is this? This is -3 and -2.63. And you may go on, because this is the numerical methods by which you can get the solution. So we get the solution like, or we can take the breakaway point as -2.6. 6 3. Okay, so this is the way how you can get the breakaway point for any equations which polynomial is having higher degree than 2. Okay, uh, there is a problem in the actually brightness. In the next class we will continue on this problem, and breakaway form point determination is complete. Now next part of the problem will be discussed in the next class. Sorry for the interruption. Thank you.